I hope you thought of some good safety things. We're going to actually make a large fire with chemicals right now. So, oh yes, each person gets to say one thing. Don't say more than one thing or you're fired. So that way everybody gets to say, there's more than enough things to say for everybody to say one thing. So once I ask for the next thing, don't bombard me right now. If you know something easy to say, go ahead and say it, and then you don't have to say anything else until I say, okay, now let's, if you've said something, you can say something again, right? So goggles, fine. Okay. Have goggles. Who's next?
Fire extinguisher.
Fire extinguisher, good. I need to know where that is. Where is it? Yeah. Is it? Look at the little needle on the top of it. Is it green? It's in the green.
Yeah.
Okay, good. It's been inspected probably in the last year with that tag. Probably fine.
On the look for that. So.
Okay, well, we checked earlier. It is. That's fine.
All right.
What were you gonna say? Thanks for raising your hand, by the way.
I was gonna say that, but tie back long hair.
All right, tie back long hair. Thank you. Oh, everybody always says goggles before the hair, and then I have to. Okay.
More important.
Cole, we could have had you doing this, and then you could have tied up your hair. Would have been fun.
I totally could have done that.
Yeah. Oh man. Oh. Didn't sound good. Okay, now the goggles. All right. Who's next? Does somebody back there raise their hand? I should probably do the names, but.
Eyewash station.
JC Power. I need to know where the Eyewash station is. Good. Here and here. While we're on it, when does Eyewash station not work on your eyes?
If you have contacts.
If you have contacts, Eyewash station will wash your contacts and not underneath your contacts. So, but you might get chemicals underneath your contacts. So, we're not doing chemicals in here, so it's not a problem. But if you're doing a chemistry or biology lab, I mean, there's physics labs with chemicals, but not in here. Don't wear contacts in lab. Take them out before lab, and that way you don't get the chemicals underneath them. It's bad. Is there anything that I might be wearing that a chemical might get trapped underneath?
Long sleeves.
Okay, my long sleeves, sure. They might soak into there, and I wouldn't be able to wash it off easy. Anything else?
Glasses.
Yeah, my ID is dangly. I need to take this off. Good.
What?
My watch. I hadn't thought of this before today, but first period and second period, thought of my watch, and I was like, you know what? That's right. Chemicals could get trapped under there. And then that gave me a good segue to talk about contacts, but we did Eyewash first, so good. Okay, remember you're only saying one thing, so if you've said one of those things, don't say anything else. What were you going to say?
The fire blanket.
Fire blanket, good. Now, how do you know whether to use, if a chemical is more suitable for a fire blanket or a fire extinguisher? If a fire happens in the lab, what's the first thing you do? Tell the teacher, good. Y'all are the first ones to get that right quickly. The rest of them are like, good, stop, drop, and roll. Because the teacher knows, like, if the certain chemical is more suitable for if the fire extinguisher is going to interact with it in some reason, in some way. Oh, where are those keys, Cole? I've got here you go. Okay, sorry for the interruption. In case you get mixed up, Cole, this is 72 key. In case you go out there today. Well, what'd you say?
Fire blanket.
Fire blanket, good. Yeah, fire blanket. Tell the teacher if there's a fire. Good. What's the other thing you got over there next to you?
The emergency stop thing.
Emergency stop button, that turns off the electricity and the gas and the water. So if there is some emergency where the water's broken and we need to turn it off, in your house, like if your pipe breaks and you can't turn it off at the faucet, then you turn it off at the street. Well, this is how we do that here. We can turn it off for just the classroom. Or if there's an electrical fire, it turns the electrical off. Or if the gas somehow turns on, we're not going to use the gas? Question mark. We will use the gas once. I found a thing we're going to use the gas for. Then that'll also turn the gas off. It also turns the vent on in case we spill something with lots of fumes. It turns the whole class vent on, not just the vent hood. Awesome. Oh, and I guess, Cole, would you take the other bell schedule down now that we don't need it? That's great. I hate having to walk closer to there to read the bell schedule. Am I ready for chemicals yet? Gloves. I hate wearing gloves. Okay, am I going to be ready for chemicals after I put on my gloves?
Apron.
Apron, okay. Apron. Okay, after I put on my apron, will I be ready for chemicals then? Will my station be ready for chemicals? Nobody? What's next? After I put on my apron, I think I'll be good with equipment. So if you look at our agenda thing, we will know proper safety equipment, knowledge, and practices. So got a bunch of equipment. I think we're good with that. So let's focus on knowledge and practices. We did some of the knowledge with the Eyewash and the fire blanket and fire extinguisher and the button. Yes.
You have to move the water bottle away from where you're doing it.
Yes, don't need a drink in lab. Thank you. That's the first time I've done that, actually. This is oh, stop it. I think my station is good now. I'm not going to burn up the flags, which would be good to not burn them. And this is going to be a long video. Anybody else? Something else we need to know? Yes.
Where the exit is.
Yes, the exits. If this thing catches the ceiling on fire and it goes, catches the whole ceiling on fire, where are the exits? And there. See, it's got the exit signs. So exit there, exit there. So if this whole ceiling area did catch on fire, like the fire drill, the fire plan says that we go out that door and onto the grass and wait to tell for it to be over. But if the fire's up here, y'all in the back don't want to walk like 10 times closer to the fire to come out that door, especially if you don't know where it's going to spread while you're walking up here. We would probably go out that door to use common sense. What's that? Oh. So the fire drill says we go out that door, out the double doors, on the grass, and I have no idea how that would work if we're doing that on during this time, like staying 6 feet apart, and not standing where the cars drive and the fire trucks drive because no one get run over. All right, great with the fire knowledge. I don't know if I got to tell this story last class. So I did a science camp 1 year, and it's for teachers where you go and you do 2 weeks of professional development, but it's also for students. In the second week, the kids come and you teach the kids the science stuff that you were preparing for the first week, and it's pretty cool. One of the people that was at the camp with me wore a lot of like foundation makeup on their face, not like super heavy, but like enough you notice. And later in the week, she told a story that made it clear why she does that. And she was carrying a beaker of acid. See, this is not a good story. And she dropped it like on the tabletop, not on the floor, and it splashed all over. She was wearing gloves and goggles and an apron, but she had acid all over her goggles and her apron and her face. So, sweet. Can you take this stuff? Hey, get him to come back. Hey, you need this shot.
Would you also bring the manila folder and the inspection sheets that are behind my seat?
Okay. So she had acid all over. Sorry for the interruption. Oh, sorry for the interruption again. Oh, okay. She had acid all over her. What does she do? What's the right thing to do if that happens in lab to you?
The shower.
The emergency shower. She went over there and she pulled it and it flooded her classroom. How long are you supposed to stand there, which is the same amount of time you're supposed to wash your eyes out for? 15 what?
Minutes.
That's right, 15 minutes. 15 minutes. Good. It's a long time. Her classroom was super flooded, but that's what you're supposed to do. 15 minutes, yeah. And this shower, we might get to demonstrate it today. It makes a lot of water. It's a lot. If not, we'll demonstrate it another day. That's what this thing's for. Yeah, so she's there for 15 minutes. All right, I think we've got all our knowledge and equipment. Let's do some practices. How am I going to light the fire here? What are some good safety practices for me to do lighting this fire? Anybody?
To not light the fire.
I mean, but we have to it's for science. It's for science. It's a fun way to do lab safety, really. Should I light the fire like this?
No. Lay it down.
That would be bad. Light it how?
Lay it down.
Like not like this, but like this?
No, like lay the.
Lay this thing down?
Yeah.
I don't know about that. When I light this, it's gonna go, and I don't want to point it toward anybody. But that's a good point. Like, don't point it toward anybody. I mean, I could lay it down and point it away, but that's at the alcohol. That's not good. So I would want to stand far away from it. Another thing I wouldn't want to do if my lab partner is lighting it, I wouldn't want to say, like when my lab partner is about to light it, I wouldn't want to go. That is an example of what that you're not supposed to do in lab? Horseplay, good. What if I get it full of alcohol and I spill it on the floor? And what if it's on fire at that time and the floor is on fire? What do I do to get away from the fire here?
Run.
I would not run nor jump because there's slippery stuff on the floor. I do not want a secondary injury.
Can you like?
I carefully move away from the fire. Yeah. So don't run or jump. All walking, no horseplay. Blah 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 blah. Yeah. Why is it so foggy now? Come on. Well, I think I'm ready. Are y'all ready? You had enough waiting for me to light the fire? This. I've been using this one, but it's gone. So these are both properly labeled alcohol containers. So, all right. While that's draining, this is not going to balance. I will do that later. I can't go that way now. Please hold. Sorry. This is pretty cool to watch, so you may want to video once we're ready. I'm going to explain what I'm doing right now. So I'm putting the chemicals that we're going to burn into the container. We're going to burn them. And I'm putting it all in here, and I'm letting it coat the sides of this thing. The reason for this is so that if the whole sides of this get coated, the more surface area is coated with this liquid, the more the liquid is evaporating into the container, and the more vapor will be in the container ready to burn, because the vapor is what burns. The liquid doesn't burn. Vapor is actually the only thing that burns. Wood is a solid, and wood does not burn. You put a match next to it, it heats it up. The sap and whatever else, like the sap boils, turns into a vapor. The wood might sublimate and go straight to a gas, and that's what burns. Liquids and solids don't burn, only vapors. That's what fuel injectors do in a car. They spray fine particles of liquid in, and that they evaporate right away because lots of surface area and all those fine particles.
Educators and scholars.
No.
Please excuse the interruption.
Maybe.
All scholars who have either Coach Morris, Coach Maloney, or Mrs. McGee for fifth period
Maloney
will now eat B lunch. Report to these classes at the beginning of fifth period. Again, all scholars who have either Coach Morris,
He sounds so
Coach
tall.
Maloney, or Mrs. McGee for fifth period need to
This
eat
is
B
not what it sounds
lunch.
like.
Report to these classes at the beginning of fifth period. One hopes that your quest for excellence shall continue unabated.
Is he?
It sounded a little like Walmart shoppers or something. That was interesting. All right, lights. Will you turn on the lights, please?
Oh.
They're clean. I cleaned them. Okay, are you ready?
Yes.
Phone's ready.
That's cool.
That was slightly different from before. I wonder, this is the first time I've used this other container of alcohol, so I wonder if there's something weird with that. They're both supposed to be 70%. Interesting. It was more powerful before. Huh. Okay, I can't use this container right now to do it again. Why not? What does fire need to burn?
Oxygen.
Oxygen. Can you see me? It's dark. What is this container full of?
Carbon dioxide.
Carbon dioxide, because in our combustion reaction we just did, all the oxygen was consumed and the fire produced, or the reaction produced carbon dioxide. All right, let's see if, I don't know. I wonder how this will work.
Maybe oxygen level?
I don't know. Maybe the alcohol has been burned more, even though this alcohol was more brown or black. I did move that one over there to pour it out, and I was like, wait, what am I doing? I hadn't done that before, so we'll see. See if this works. All right. All right, Cole, you ready?
Yeah.
There we go.
Ooh.
Weird. I don't know if I can do it again. I might try just to see if we can figure out why that was different from the other classes. I've got a vacuum pump that's sucking out the carbon dioxide and bringing in air from the room. So maybe that'll work better. So let's talk about what happened though. Flame did shoot somewhat forcefully out of the top of it, right?
Yeah.
That wasn't just less dense air rising. It wasn't just floating, it was actually shooting up. Why did it do that? Will you turn the light back on? Oh. Wow. Oh, it's so bright.
It's the pressure that.
Thank you. Fix up the rest of my sheets like this, where it says NA, NA, NA. 111, 111, 111. Don't worry about the last 3 digits. And do consecutive dates until you run out of sheets. Always +2. Don't write my name. Do one and I'll make sure you get it right. Don't mess with the check marks. Just the NAs. Oh. I think we're done with this. I'll have to edit it to cut off that last part.